about the physical properties of alkaline earth metals. So, which elements do we find in alkaline earth metals? Jade, glory. Yes, those are the elements we are going to see. And in the physical properties, we are going to look at the atomic size, the ionic size, melting point and boiling point, and the ionization energy. And we are going to focus on the three elements, which are beryllium, magnesium, and calcium. And you know, the atomic size of beryllium has 2 electrons in the innermost energy level and 2 electrons in the outermost energy level. Magnesium has 2 electrons in the lowest energy level, 8 in the middle energy level, and 2 in the outermost energy level. Calcium has 2 electrons in the innermost energy level, 8 electrons, the other 8 and 2, making up a total of 20 electrons. So, as you can see, beryllium has a total of 4 electrons and calcium has a total of 20 electrons, meaning the atomic size increases down the group. Can you be quiet? Then, when it comes to ionic size, alkaline earth metals react by losing 2 electrons in the outermost energy level in order to be stable. So when beryllium loses 2 electrons, how many electrons are they going to remain? 2. As you can see, all of them has 2 electrons in the outermost energy level. That's why they are considered to be in group 2. When they react, they lose, this loses 2 when it comes to iron. The 2 you see here shows the number of electrons being lost in order for the atom to be stable. And when we come to the atomic radius, beryllium has 0.089 and calcium has 0.174, meaning atomic radius increases down the group. This is due to the increase in the number of energy levels and increase in the number of electrons from beryllium down to calcium, leading to increase in atomic radius. Ionic radius also increases from beryllium to calcium. Because you see beryllium loses 2, it retains 1 energy level. Magnesium retains 2 energy level, and calcium has 3 energy levels after losing 2 electrons. This is 8. So beryllium has the smallest atomic size because it has the least number of occupied energy levels. Calcium has highest atomic radius in the first 20 elements because it has more occupied energy levels due to the increased number of electrons. And when we come to another physical property, like magnesium and calcium has luster. And it loses luster when it reacts to air because it gains the oxide layer due to reaction with oxygen. Because, for example, calcium reacts with oxygen to form calcium oxide. This forms the luster, and that's why when we come to the other part of reactions, calcium and magnesium will have to be scrubbed in order to remove the oxide layer from the outer surface for it to properly react to the other chemicals. The purpose of polishing the surface is to remove the oxygen. When you scrub, you remove this oxygen over here. When it comes to cutting, there is another element which is harder than the other in cutting. For example, if you try cutting calcium with a knife, it won't be possible, unlike magnesium, which will be easily to cut. But magnesium also is hard because it's ductile and malleable. I know what's the definition of ductility? One of you define the word ductility. Yes, Yosha?
Ability to change into other shapes.
Ductility is the ability to be drawn into wires. And what's malleability? Malleability is ability to be drawn into sheets. And I think you know the difference between wires and sheets. Who doesn't know? Okay, we move to the next part, which is the melting point and the boiling point. Calcium and magnesium are good conductors of electricity. Who knows the reason? Reason for conduction? Yes, yes.
Presence of localized electrons.
Yeah, the presence of two delocalized electrons in the outermost energy level allows calcium and magnesium to pass electricity. Okay, let's continue. That's why let's assume we have an electricity wire which is not completely joined. If you put calcium or magnesium in between the wires, it will pass the electricity from the other wire through that connection to the other one, meaning it conducts electricity. And also heat, meaning it allows heat to pass through. If you heat, you'll feel the heat on the surface of either calcium or magnesium. Now let's come to the melting point and boiling point of beryllium, magnesium, and calcium. see melting point decreases down the group. Who knows the reason why melting point increases down the group? Decreases, I mean. You don't know. Let me answer that. Melting point of beryllium is higher than the other two because, as you can see, beryllium has the smallest atomic size and it has the smallest ionic size, meaning the two electrons here are closer to the nucleus, and the closer the electrons are to the nucleus, the stronger the charges in between them. And in order to break the forces between the two, it requires high amount of heat. And the boiling point also for beryllium, it's higher than that of calcium and that of magnesium because of the same reason. And what's the reason I've stated? You mean you are not listening to whatever I was teaching?
Because of atomic size.
Yeah, the smaller the atomic size, the closer the electrons are to the nucleus, and that leads to higher charge, which needs high amount of heat to be broken. Have you heard? Yes. Okay, for the first time you are listening. Let's move to the next part, which is the ionization energy. What's ionization energy? Yes, please.
It's the minimum amount of energy required to remove an electron from the atomic energy in the state.
Clap for her. And there are two types of ionization. There is first ionization energy and the second ionization energy. In the first ionization energy is the minimum amount of energy required to remove an electron from the outermost energy level. And when it comes to the second ionization energy, it's the minimum amount of energy required to remove an electron from an ion. Because when you remove the first electron from the outermost energy level, meaning you are remaining with an ion, and that ion, when it loses the second electron, that's the second ionization energy. Have you gotten the difference?
Yes.
Okay. And when it comes to another difference between the second and the first ionization energy, the second ionization energy is higher than the first ionization energy. That's because in the second ionization energy, you are losing an electron from an ion, but in the first, it was just an element which has not lost any electrons. Okay, in conclusion of today's lesson, I think you have gotten the difference, the trend in atomic size, the trend in ionization energy, and the trend in melting point and the boiling point in alkaline earth metals. And what's the trend in atomic size? Mass? The trend in atomic size. Jaylin, what's the trend in ionization of energy? Yes, ionization energy decreases down the group. And what's the trend in the melting point and boiling point? Ezra? Trend in boiling point and melting point of group 2. Yeah, it decreases down the group. For your assignment, you go to KLB, page 52 and 53. You do question 1, 2, and